Right, so I made one mistake here. With these two distance, like when you sum up the distance of these two terms, it should be less than epsilon 1 plus epsilon 2, and it should be less than d1, because when we define epsilon and epsilon 2, it's definitely less than d1 here. Okay, so make a correction here. Then is the next definition, bounding. In the metric space, let's say that the set A is within this metric space, and if that set is bounded, then there exists a point in the universal set X, and you can also find a distance epsilon that is larger than 0, such that for all points in that set X, in that set A, should the distance between those points and the point that you pick, small x, should be within that distance. So what does that mean in terms of graph? So once again, we look at the example in the real line here. Says that now the set or the sequence AN here is in this universal set R. Okay, so if this set is bounded, that means there exists a point in the universal set, which is R here, and I pick the small x here, and based on this point I can find a distance epsilon that is going to contain all the elements in this set A within this interval. Okay, so that is what we call bounded. You can imagine that there's a very big ball that is going to contain the whole set within that ball. Okay, once you figure out once you pick up the reference point x here. Okay. Right? Yeah.
So the E here is not like in convergence that E is always bigger for every E bigger than 0. It's just a random E.
Oh, you mean the epsilon?
Yeah. The epsilon.
Your question is?
Because in the part of the convergence, E should be for every E larger than 0.
Yeah.
But here, E is just a random.
E is a random number. I mean, like once you fix the reference point x, the epsilon should be larger enough to cover, like to contain all the elements, right? Right. So in that sense, it's not really random. It should be large enough.
Larger than all.
Yeah. Yeah. Oh, and of course, like you can still write it in a way that your distance or like your how to say it, your range should be depending on your reference point that you pick. That is going to has to larger like to a certain don't confuse it with the definition of convergence. I just like put, maybe I should put a big D here, like some constant number that is large enough to cover all elements. Right. Okay, then I'm going to prove that the convergence sequence is bounded. So what questions ask is that we already know a convergent, the sequence is convergent. Okay, so we denote that sequence as xn, and as n goes to infinity, we know that it converges to x star here. And based on the definitions of convergence, we know that for epsilon larger than 0, there is a big n in the natural number such that when the small n passes the big N here, the sequence will get close to the convergent point x star, close enough. So which means smaller than the epsilon here. Okay, then we pick we use that convergent point x star as the reference point and pick up our distance, which I denote as epsilon bar here. So the way I pick it is that, okay, so we already know that when small n larger than big N, then it falls between that criteria epsilon, right? So what I'm going to deal with is the rest of it, which is started from the first element to the big N, right? And then because it's finite, it's countable, so you know the maximum distance among this point relative to the convergent point x star. Okay, so we already know the max of this set and compare this one with the epsilon and take the bigger one and call it epsilon hat. And then we find the criteria epsilon bar here. So by using the convergent point x star as the reference point, and we put